Welcome to another math lesson. Today we're going to start our warm-up by doing a few fact triangles. And I'm going to do the first fact triangle with you, then I'm going to leave the next three for you to figure out on your own. And after that we're going to do one word problem. So here we go, our first fact triangle. I have 36 as my target number, and one of my factors is 6. So I have to figure out, I can do this 36 divided by 6 to get this number, or I can say 6 times what equals 36. And I know that 6 times 6 is 36. So I'm going to put a 6 right in the spot. So this is my fact triangle. What I want you to do is go and find out what numbers go in those spots in those fact triangles. And then when you're done, I want you to write at least one fact family. So pick one of these fact triangles and write a fact family for it. After that, we have a word problem for you to work on. And this one is, Miss Piggy received 8 birthday cards. Each card had $12 inside. Cookie Monster received 3 cards, and each of his cards had $32 inside. Who received the most money for their birthday? Okay, what I would like you to do is to get out a piece of paper and a pencil, work out these problems, or pause your computer, work out these problems, and then come back and check what and see what I got for an answer. Good luck. Okay, to work on this one, I have 7 times 6 is going to give me my target number. So 7 times 6, if I didn't know that fact, I would do 7 times 5. I like to break it down. And 7 times 5 is 35. Then I need one more group of 7, so my answer would be 42. So 42 would fill in that question for me. On this one, 24 is my target number. I have 8 times something is 24. And if I double 8, I get 16. If I have 8 more, I'd get 24. So that's going to be 3 8s. So it's going to be 8 times 3. Next one, 7 times 4. I can double 7 and get 14, and double 14 and get 28. So this answer is going to be 28. I'm going to write it up here. So the next part is I asked you to find a fact family for these. So I'm going to do all of them for you. So I can say 7 times 6 equals 42. 6 times 7 equals 42. 42 divided by 7 equals 6. 42 divided by 6 equals 7. 8 times 3 is 24. 3 times 8 is 24. 24 divided by 8 is 3. 24 divided by 3 is 8. Next problem, 7 times 4 is 28. 4 times 7 is 28. 28 divided by 7 is 4. 28 divided by 4 is 7. Fact triangles are something that we work on a lot to practice our facts. And I'm going to give you one hint about 4th grade. If you know your multiplication and division facts, 4th grade math is going to be easy. Okay, next thing I have to do is, whenever I get a word problem, I always like to go in and read the last part of it first, because if I can figure out what they're looking for, a lot of times the problem becomes easier for me. So who received the most money for their birthday? So who received the most money? So I think I'm going to have to compare those two. So I have 2 people, so I'm going to divide my paper into 2 pieces. I'm going to put Miss P for Miss Piggy here. I'm going to put down CM for Cookie Monster on this side. I'm going to read Miss Piggy first. So Miss Piggy received 8 birthday cards. So I know she has 8 cards, and each one had $12. I think of that equation, I'm going to write down 8 times 12 for Miss Piggy's side. For Cookie Monster. Cookie Monster received 3 cards, and each card had $32. So his equation is going to be 3 times 32. Okay. So I'm going to go over and find out Miss Piggy's. Let's do area model for Miss Piggy. So I'm going to draw my rectangle. I'm going to break that 12 up into a 10 and a 2. I'm going to put an 8 right here. So 8 times 10 is 80. 8 times 2 is 16. So 80 and 16 is $96 for Miss Piggy. That's a pretty good birthday. Now I have my friend Cookie Monster. I'm going to do the standard algorithm for his. 3 times 2 is 6. 3 times 3 is 9. And he received $96. When I look, it looks like they both had the same amount of money. Both of them had good birthdays. Okay? Now we're going to do a little bit more math. I'm going to try to keep this lesson around 10 minutes for you. So get your piece of paper out and we'll be doing a little bit more right here in a second. What I'd like to work with you a little bit on is numbers, multiply numbers that end in 0. So first thing I want to do is, I want to do 4 times 6. I know 4 times 6, I can double 6, get 12, double 12, get 24. So 4 times 6 is 24. Now, this problem got a little bit harder because there's a 0 on the end. But actually, it's no more difficult. If I know my front end fact is 4 times 6, that's 24, and then I'm just going to put a 0 there. Because if I did this standard algorithm, 4 times 0 is 0. 4 times 6 is 24. So that is going to be 240. Now when I do 4 times 600, I'm just going to do that front end multiplication again. I can get 24. And I have those 2 zeros I'm going to just tack on the end. And I'll show you why I can do that. I get 600 times 4. 4 times 0 is 0. 4 times 0 is 0. 4 times 6 is 24. So what I'm noticing that if I multiply numbers that end in zeros, I'm just doing my front end multiplication and putting on that many zeros on the end of it to hold as place value. I'm going to try to see what you can do on this one. Do this problem for me. See if you think it's any more difficult. 4 times 6,000. Looks really tough, but if you follow that rule, it's not too bad. I can do 4 times 6 is 24. And I just have to tack on those 3 zeros, and I'll get 24,000. Okay. So hopefully you're finding that's not a real difficult thing to do. I'll put up another problem, and so a little problem string for you and see if you can solve those for me. Okay. Take a few seconds and see if you can solve these three problems for me. If you remember what we had on that last one, these should not be too difficult for you at all. Okay, so let's see how you did. First fact, I think you guys are going to be getting fairly easily now. Because 3 times 7, I can double that 7, get 14. One more 7 is going to give me 21. Now, if you remember back to our last ones, 3 times 7 is going to be 21. Then I have to tack on that 0 for that placeholder again. I tried to fool you a little bit by making it 30 times 7. But if you remember what we did, you just have to do that front end multiplication again. 3 times 7 is 21, and this number has a 0, so I just have to tack that 0 on again. Now, does this make sense to you that if I had 3 70s, it's the same as having 7 30s? Because both those have the same answer. Let's see if you can get this one. Now, if you remember back, do your front end multiplication. I have 7 and times 3 is 21. And I can tack on my 2 zeros. And that would be my answer. Okay. Let's do one more. We'll see how you do with it. Let's see how quickly you can get through this set of 4 numbers, or 4 problems. Okay, so you would have 5 times 9 is 45. 5 times 90, I would do that 5 times 9 to get my 45. Tack on that 0 again. 5 times 900, 5 times 9 is 45. I have 2 zeros. Try to trick you a little bit again. 5 times 9 is 45. And how many zeros? 1. So hopefully you're not afraid of multiplying by numbers that end in 0. That's going to be it for our lesson today. And I will show you the pages you have to do for your work today. In your home connection book, you have pages 127 and 128. Now, you might notice this lesson only took 10 minutes. That's because a lot of people are complaining because our lessons are too long. But anybody that wants to stay on and do an extra enrichment with me, I'm going to do about 15 or 20 more minutes of enrichment math. So if you want to get challenged, stay with me. If you want to leave, go and do pages 127 and 128. Then do some Dreambox and do some multiplication.com. So enrichment people, get your paper and get your pencil and get ready for some more difficult math. Okay, enrichment people, here we go. Before we figured out the circumference of a circle, and our formula for that is 2 times pi times the radius. So I gave you another problem. This is 8 centimeters for the radius of this circle. Oh, now it's going to be silly on me. Hold on, I'm going to go check something. The smartboard, I don't always get along. It's working again. So I have 8 centimeters. I have to do 2 times pi times the radius. Now, since this is a multiplication problem, I can do 2 times pi and then multiply by the radius. Or I can do 2 times the radius and multiply by pi. Or I can do the radius times pi and multiply that by 2. Doesn't matter. I'm multiplying 3 numbers together, so I can do any of them. So I can do 3.14 times 2. 2 times 4 is 8. 2 times 1 is 2. 2 times 3 is 6. Now I have those decimal points in there, and I always tell you guys, forget about the decimal points till you're done. Then you have to figure out how many spots past the decimal point there are. There are 2, so you have to move it over 2. So I have 6 and 2800ths, and I have to multiply that now by the radius. So I have 6 2800ths multiplied by 8. I'm just going to write it down and do standard algorithm, multiply by 8. 8 times 8 is 64. Put down my 1s, carry my 10s. 8 times 2 is 16, plus 2 is 22. Put down my 1s, carry my 10s. 8 times 6 is 40, plus 2. Or 48, plus 2 is 50. I have 2 numbers past the decimal point. I have to move it over 2. My circumference of that circle is 50.24 centimeters. Okay. Now to find the area of the circle, I have pi times the radius squared. I'm going to let you try to figure this one out. So I'm going to pause it for a second. You try to figure it out and come back and check and see how you're doing. Okay. So the tough part about this is the radius squared. If I remember, if I have a number with an exponent, I have to just do that number twice. So I have 7. So r squared here is equal to 7 times 7. Sometimes you can see multiplication as a dot on some problems. If it's down here, it's a decimal point. If it's in the middle, it's 7. So radius squared is going to be 7 times 7. So 7 times 7 is 49. And I have to do 49 times pi, which again, I'm going to use 3.14, even though that's just a rounding off of a number that goes on to infinity. So I'm going to put 3.14. And 7 squared is 49. I'm going to multiply by 49. Now, a little thing that I like to do, whenever I have numbers with 3 digits and 2 digits, I always like to multiply with the 2-digit number on the bottom. It just makes it easier than if I put the 3-digit number on the bottom. I could write it 49 with 3.14 on the bottom, but it just doesn't work well for me. And I'm going to do this standard algorithm. So I'm going to forget about that 4 and just multiply by the 9. 9 times 4 is 36. Put down the 6, carry 3. 9 times 1 is 9, plus 3 is 12. Put down my 1s, carry my 10s. 9 times 3 is 27, plus 1 is 28. Now I'm all done with that 9, so I'm going to start to multiply by the 4. I'm going to change colors so you can see that I have to have a second row. I have 4 times 4 is 16. Put down my 1s, carry my 10s. I'm going to put a line through that 3 because I used it already, and carry my 1. 4 times 1 is 4, plus 1 is 5. I've already used this, so I'm going to put a line through it. 4 times 3 is 12. plus 1 more is 13. When I add these together, oh no, you guys might have noticed, I forgot Waldo. I multiplied by a 4 and didn't put my place value down. I was seeing if you guys realize that. So what I have to do is go back and do this part over again. Because I multiplied 40 times 4, and I got 16. But it's actually 160, so I can't have anything in that spot. So I'm going to go back and do the whole problem over again to see if you caught my problem, my error. So 36, put in my 1s, carry my 10s. 9 times 1 is 9, plus 2, 3 is 12. 27, 28. Now I have to put down Waldo because I'm multiplying by a 10, not by a 1. 4 times 4 is 16, put down a 6. I use that. 4 times 1 is 4, plus 1 is 5. 4 times 3 is 12. When I add these together, I get 6, 8, 3, 1, 5, 1. 2 spots past the decimal point, so I can move it over here. I get 153 and 86 hundredths. Or 86 hundredths, and that's going to be centimeters squared for that one. Okay. Did you catch my mistake? Sometimes I do things on purpose just to see if you caught me. Okay, here we go. Next thing I'd like to work with you a little bit on is finding surface area. If I find volume, I want to find how many squares would fit in this whole thing. If I find surface area, I want to find the area of the face, of each of the faces of this rectangular prism. So to find the surface area, I have to find the area of this face, this face, this face, this face, the face in the back, and the face on the side. Now, to find the area of this face, I know that it is 6 long, or 6 deep, and 8 long. So length times width, I'm going to have 8 times 6. That's going to give me 48 centimeters squared. Okay, I'm going to change colors. I don't see that color. Okay, so this one, to find this face right here, I have 8. It's going to be 8 long because this edge is 8 and 4. So 8 times 4 equals 32 centimeters squared. And then I have to find this face on the end. And this face, I know it's 4 high because I have the 4 from here. And I know it's 6 deep because I have the 6 from there. So I have 6 times 4. So 6 times 4 is 24 centimeters squared. So I figured out that this face is 48 centimeters squared. This one is 32 centimeters squared. This one is 24 centimeters squared. Now, if you notice something, I've only found 3 of the faces. I know there's a face on the back, and I know that face is going to be the same as 32 centimeters squared. I know there's a face on the bottom. I know that's going to be the same as the 48 centimeters squared. And I know there's a face on this side, and I know it's going to be the same as 6 times 4, which is 24. So I'm going to take this total and multiply it by 2. So if I get 48 plus 32, I get 80. Plus 24 is 104. I multiply that by 2, I'm going to get 208 centimeters squared is the surface area of that rectangular prism. Now, surface area is something that I saw some of my kids had on map testing, and they weren't exactly sure how to do it. I said, someday I'll teach you how to do that. So this is what you're going to do if you ever get surface area. I'll give you a couple more problems like that later in the year. Okay, let's do a couple more problems. We got into adding fractions a little bit last time. So I have my fractions, and remember, the denominator tells you how many pieces your item is cut into, your whole is cut into, and the numerator tells you how many pieces you're talking about. So I'm going to cut both of these into ninths. And an easy way to do ninths is I'm going to cut this into thirds. I'm going to try to make these equal. I'm not always equal. I try my best. And if I'm really smart, I'm going to take these right down since I'm doing ninths. On both of these, I'm going to take my thirds down. And then to make this into ninths, I'm going to cut my thirds into 3. And I can cut this, and I just cut my rectangles into ninths, and hopefully they're even. Okay, on my first one, I have 7 ninths, so I'm going to color in 7 of them. 1, 2, 3, 4, 5, 6, 7. On my second one, I have 5 ninths. 1, 2, 3, 4, 5. Now, if I want to add those together, each of these wholes is only cut into ninths, so my denominator is going to stay the same. So when I add fractions, denominator stays the same. Now, how many ninths do I have total? 7 plus 5 are 12 ninths. So 5 ninths plus 7 ninths are 12 ninths. Now, let's see if this works for me. I could take this ninth. Is that going to move? Nope. I'm going to take this 4 and move it up here. I'm going to take this 5 and move it up here. And now, if you look and see what I have 1 whole and 3 ninths left over. So 12 ninths is equal to 1 whole and 3 ninths. Then some kids are going to notice that 3 ninths, if I cut this way, is the same as 1 out of 3. So that's 1 whole and 1/3. This is a correct answer. This is a correct answer. That's also a correct answer. All those answers are the same. Okay, let's do another one. And let's see if it's on the next page. Is it there? Oh. Do another one at you. This one you're going to have a little bit of problem on, though, because my denominators aren't the same. And it's kind of like trying to add apples and oranges. I can't add things with denominators that aren't the same. I'm going to go ahead and draw these two out for you and see if we can do something to make this so I can do it. So I'm going to cut this first one into fifths. And again, I'm going to try to be equal the best that I can. And I know that if I cut this into fifths and cut my fifths in half, I'll get 10. So I'm going to bring these fifths straight down. So even if they're unequal, they're as close as we can get. And I'm going to cut my fifths in half, and I'm going to get tenths. And we just figured out that I can't add together fractions who have denominators aren't the same. So I'm going to go like this. I'm going to cover in my 4/5 here. And I was just thinking, when I cut my fifths in half, I got tenths. Could I not just cut this in half and make these into tenths? So I just made an equivalent fraction. I just figured out that 4/5 are equal to 1, 2, 3, 4, 5, 6, 7, 8 tenths. So I changed 4/5 to 8 tenths. And I did that by multiplying this by, I can multiply each of these numbers by 2. Now I'm going to color in my 7 tenths. So I changed my 4/5 into 8/10. Those are equivalent fractions. I can do that. And I ended up with, my denominator is going to be the same because everything's still cut into 10 pieces. And I have to add 8 plus 7, I get 15. So I get 15/10. Now, I'm going to do the same thing I did in the other one. I'm going to take this 10th and move it up to here. I'm going to take this 10th and move it up to here. Now I have one whole, and I have 5 left out of 10. So 15/10 is equal to 1 whole and 5/10. And I realize that 5 out of 10 is exactly half of this. Half is colored in, half isn't. So I have 1 whole and 1 half. These are all equivalent fractions. This is called an improper fraction because my numerator is bigger than my denominator. This is called a mixed number because I have a whole and a fraction. And this is the lowest terms for that fraction. Okay. Last week I gave you some other problems to work on multiplication. Let's try a couple of those today. I'll work out the first one with you, and then I'll leave the second one for you to work out, Sam, you did. So this is a problem with some numbers that are missing for me. And first thing I have to notice, I have to multiply something by 6. And my number has to end in a 2. And this is another hint. My 10s are 4. So I have 2 1s and 4 10s when I multiply this number together. So what multiplied by 6 is going to give me 42? And I know that's 7. So I know that number is a 7. 7 times 6 is 42. Put down my 2. Put down my 1s, carry my 10. Now when I multiply this 7 by this number, I'm going to get 32 after I add 4 to it. So 7 times something plus 4 is 32. So to figure this out, I'm going to take 32 and take away 4. That's going to give me 28. 7 times what is 28? And I know that number has to be 4. 7 times 4 is 28, plus 4 is 32. Now I put down my Waldo. Remember, I forgot that in my other problem. It's there now. 7, I've all done my 7s. I'm going to multiply by 2. Waldo's there for the placeholder. 2 times 6 is 12. Put down my 2, carry my 1. 2 times 4 is 8. Plus 1 more is 9. So if I add this problem together, I get 2, 2. Oh, why am I making mistakes today? It must be one of those days for me. Okay. You have this problem to do on your own. So pause your computer, work it out, see if you can do it, and I'll come back and help you with it. Hopefully these are making you think a little bit and stretching you some. I know these are type of problems you'll see in 4th and 5th grade. So this number, I have to have a number times 4 that's going to give me 0. The only number I know that I can multiply 4 by to get to a 0 is 5. So let's see, if I did 4 times 5, that would give me 20. I would put down my 1s. Oh, it's got to be 20, because there's a 2 in my 10 spot up there already. So this has to be 5. So 4 times 5 is 20. Put down my 1, carry my 2. Now, 5 times something plus 2 is going to end in a 7. So that number could be a lot of different numbers. So 5 times 9 would give me 47. Ooh, I'll give you a hint. I should have written down an answer down here. Again, making a mistake today. Not good. So this number here, it has to equal 8 together. So this has to be a 2. So 5 times something plus 2 is going to give me 27. So the only number this could be is 5. 5 times 5, is 25, plus 2 is 27. Okay, I'm all done with the 5, I can do the 3. I have to put down Waldo. 3 times 4 is 12, so I'll put down my 2, carry my 1. 3 times 5 is 15, plus 1 is 16. If I add that together, I get 1890. I kind of messed up that problem a little bit on you again. It's been a tough day for me. I'm going to let you guys go ahead and do your work. We'll do more problems like this, and hopefully the next one I have myself on. Have a lovely day. Take it easy.